All right, yeah, so be mindful of the poor audio today. And also that means try to keep me from not walking over there too far. Otherwise, it won't pick anything up. All right, so last time we were talking about implementing the stack where we store the data in an array. We talked about, well, we could keep the top of the stack always at index 0. And the benefit of that is we always know where the top is. It's always 0. We don't need to do anything special. The downside of that is, like, look at that stack. If I wanted to add something, push it onto the top, it needs to be at index 0. But there's something already there. So I got to make room for it. So I got to move the thing at index 0 over to index 1. But the problem is something's already there. And so on and so on and so on. So I would have to move everything down 1 to push something. And if I have a million things in my stack, how many things do I have to move? A million. And if I then pop something from the stack, I remove the thing at index 0. Well, now I have a hole. The top is supposed to be at index 0, but now there's nothing there. So what do? I move everything down 1. There's a million things, I gotta move a million things. Kind of sucks. So instead what we could do is, well, just make the top of the stack the other end. The other end being that side. The top would be whatever's at index 5. If that's the case, whenever I add something, well, I just put it into the next available spot, which is index 6. Then if I want to pop something, well, I'll just remove the thing at wherever the current top is, which is index 6. Right? Now, the way we're going to implement this is, because you remember, now this is just the way I'm implementing it. You could implement it where you keep track of literally where the top is. But what I'm going to do is I'm going to keep track of the size of the stack. And the size will always also happen to be the next available spot. So we're not actually directly going to keep track of where the top of the stack is. We're going to keep track of the size of the stack, and then the size minus 1 will always be the top. If you're thinking, why don't you just have another field to keep track of the top? Then go ahead and do it. Fine. It doesn't matter. But I'm going to do it that way. So that's the idea. Any questions about that idea? I mean, in terms of the data that we want to store in the stack, we have some underlying container, this array, the thing that's actually going to hold on to the stuff I'm adding. And what else does the stack need to know? Well, how big it is and where the top is. But size and top, size is going to do double duty. Everything else, I don't really think there's any other data I need to keep track of for any instance of a stack. That's basically it. So then other than just the data that I'm going to store, so like what fields, well, what methodology do I want? Well, I want push, pop, peek, is empty, size, and our toString, our equals, and so on. Questions? That's where we're going with this. Yeah, okay. Implementation issues. What do I say here? Okay, yeah. Array, the top will always refer to the next available spot in the array. Due to the zero-based instancing, the top will also correspond to the number of elements in the stack. So I'm actually, I set it inverse. I'm not going to keep track of the size, I'm going to keep track of the top, which is also the size. But top is actually not keeping track of the top, it's keeping track of the next available spot. It is what it is. I could have done it in any variation of those things. I'm doing it this way. Push operations will always happen at top. Push to the thing at index top, right? Right now, top will be 4. We can see it right there. Top is 4, which also corresponds to the number of things in the stack. And if I wanted to add something, it should go to index 4. If I want to pop something, well, it's going to be top minus 1. It's not the next available spot, it's the spot immediately before that, which is the last thing before the available spots exist. All right. So, implementation. We're going to implement a stack with an array. Now the convention in Java, and it's kind of funny because a similar language, C#, does the convention kind of backwards. The convention in Java is if you have an interface, remember yesterday we defined the interface. And it was a whole new file. It was a .java file, but it wasn't a class, it was an interface. And there really wasn't any code in there, just other than like the signature of each individual method. We call those abstract methods. We are saying a stack has a push. In order for something to be a stack, it must implement a push method, a pop method, a peek method. It must implement those things, but there's no actual implementation in the interface. So now we actually need to implement the interface. We're actually going to write the code to make a stack. We're going to write the how. The interface is the what. In Java, the convention is when you have an interface, you call the interface like it's a stack. So the interface is a stack. But your specific implementation, can someone do me a favor and close that door? Your specific implementation will be named with its like container. So we're going to make an array stack. Okay? That's the convention. If we don't call it that, it'll still work, but everyone hates you. So we call it that. All right, the array stack will implement the stack. The stack is the interface. It defines what a stack must do in order to be a stack. The implementation is the how. So the array stack is a stack, all right, if we do everything correctly. Anything expecting a stack will be happy with an array stack. Right? If I have a reference variable for a stack, because an array stack is a stack, it's gonna work just fine. So here's the start of this class. This is how I would start it. There might be some imports there, whatever. But public class array stack, it's generic. But we're also seeing another keyword, implements, then the name of the interface I'm implementing. Now, I don't need to implement an interface to write a stack, but in order to do this correctly, I do. The stack defines what it is. I know we wrote the stack interface, but pretend it was given to us. And the person said, if you want to make a stack, it must conform to this set of rules, what's in the interface. So then you, by saying implement stack in your code, that has a guarantee for Java that if your class implements the interface, then it guarantees that what you're writing is a stack. Okay? If I say, if you do A, B, C, D, you're a stack. And then you write code and you say, I'm going to implement A, B, C, D, and I implement A, B, C, D, then I'm a stack. If I don't implement A, B, C, D, then I'm not a stack. Once we see this come concrete, I think it'll make a little bit more sense. Now, I'm going to warn you. As you start writing this class, IntelliJ will start to yell at you. And the reason IntelliJ will yell at you is because when you say, oh, I'm going to write a class that implements the stack, IntelliJ is going to go, but you're not. You didn't implement all of the methods that are in the interface. And then you go, well, yeah, I know, I just started writing it. Obviously, I'm not done yet. IntelliJ still won't shut up. It'll still say, you're not done. It's not implementing the interface. You got issues. Because you really aren't correct, and you wouldn't be able to run it either way. So I'll show you what I mean in a moment. So here, do I have another one open? Playing around. Perfect. Here's what I'm going to do. I'm going to say new class, and I'm going to say, really it's an interface, stack. Okay? And because I'm lazy, I'm just going to go and copy the actual existing stack interface. And I'll get rid of all the Java docs for now, just because it might make things a little clearer. The Java docs are just describing what the things do. It's just docs. There. There's the whole interface. Here, let me get rid of that. There's the whole interface. That's the interface. Yeah.
What's the difference between the interface and just the Java?
It was as much when I created the file, it just added that word. If I selected class, it would have said public class. If I selected interface, it says public interface. That's literally it. So there's no difference. I'll show you in one moment. So this is just the interface. It's just a list of methods, but there's no actual implementation. This is a stack. So now I'm going to go, okay, new Java class, but it's going to be a class this time, and you'll see the magic little, the fact that it includes. See, it says class now. That's literally the difference. So there we go. But I want to actually say implements. Oh, it's going to be generic. Implements stack. And immediately IntelliJ is saying, no, you didn't. Your code says you're implementing the stack interface. Where? Right there, right at the top on line 1. Public class array stack, implement stack. And that tells Java, this is a stack, because I've implemented all of the things inside the interface. And IntelliJ is saying, but you didn't. You didn't implement anything inside the interface yet. And then, like I said, then you go, well, yeah, I know, I just started writing it. And that's that, okay? So that's why it's mad at you. If I tried to run this code, Java wouldn't compile it, because it would say, no, you said you implemented the interface, the stack interface, but you didn't. So it wouldn't even work yet. So in order to get it to shut up, the easiest thing to do is just tell it to implement the methods automatically, but in doing so, it won't actually implement the methods. It just adds a bunch of like dummy methods that just exist, right? Clearly push shouldn't just return false, right? But it just added it there, so it actually is implementing the interface. As far as Java is concerned in terms of what the code says. Obviously, push, pop, peek, is empty size are incorrect, but they exist so it makes Java happy. The reason it won't even work if you say it implements this interface is by implementing an interface, you are guaranteeing that everything of this class is actually in fact a stack. It's not just an array stack, it's more generally a stack. But if it can't actually connect all those methods together, it's going to say, it's not going to happen. So it's just a way to guarantee some properties about what you're implementing. Yeah?
So the methods that are defined in the interface have to have the same names as the methods?
And the return types and the parameters all must match. Cool. And you'll see they all override. Well, yeah, it's overriding what's in the interface. These tags are not necessary. If you don't write them, it doesn't matter. Just leave them there. Okay? Questions about that? Yes?
So if the code was slightly different, but still return the same thing, would that still work?
I'm not sure what you mean.
Like if you have two different ways does the same thing, would it still accept it as like the same method?
It would have to have different parameter lists. Like I could have two push methods, but they would have to take different sets of parameters.
Okay.
Did that answer your question?
I think,
Hold on to your question, and
Yeah.
maybe it'll kind of get clear as we go, or whatever. Yeah.
thank you.
Can you re-show how you got all the methods just from yourselves?
All I did is I kind of hovered over this and was like, yeah, just implement the methods. And it won't actually make the methods for you. Like it won't write them. It'll just put in like empty methods. I know, maybe one day. Maybe one day. Actually, with ChatGPT, it would probably do it just fine. But all it is just these dummy methods that exist. So it just makes IntelliJ happy because, oh, you said you implemented this class and all the methods that have to be implemented are implemented. Great. They're not implemented correctly, but that's where tests come in. All right. So we need a constructor. Oh, wait, actually, if I go up here, we need to include our fields. Now, there's only two fields, stack and top. But we also have a static constant for the class. That's just like a default capacity like we used before with the contact list. Just some value that if they don't specify how big they want the underlying array container to be, it'll make it that size. Another thing you'll notice is with the contact list, we had an array of contacts. With the country catalog, we had an array of countries. With the courses, we had like an array of courses. Here, it's generic, so we have an array of type T. But you're going to see something that annoys you because you can't actually make an array of type T. We can make a reference variable to an array of type T, but we can't actually create an array of type T. I'll show you what I mean in a moment. So we'll start with the constructor. Let's start with this constructor. No. No, oh, my goodness. Copy.
Would that be because it has to allocate like a certain amount of memory for like each type T, but
I honestly can't remember why Java won't let you. I really can't remember why. I don't think that's why. I think it's another esoteric reason.
type T, you don't know how much memory that would take up though, so
Yeah, but the type T, an array is just an array of reference variables. Arrays are just reference variables to point, so they're like pointers to other objects. So I don't know. I'm not sure why. So here's what we're doing. Is we create a new array of type object. Okay? And then immediately we say, but you're going to be of type T. By doing this thing, that casting thing. We did this also with the equals. Remember, we had something of type object, and then when we wanted to get more specific, we had to cast. But that won't always work, so you have to use it very carefully. In this case, it'll be fine because it will be arrays of type T. Now, you'll notice that it's going to give you a warning here, and it's going to be like, yeah, are you sure you can do that? Is that actually a safe thing? So that's what that warning is. Your code will work with it, but you can also add this in. That just says like, shut up. That's what that means, all right? Suppress the warning that it's yelling at you. Other than the fact that we had to make, other than that weird extra step we had to do of like, okay, create an array of type object and then immediately say it's of type T, it's exactly the same as the country catalog. It's exactly the same as the course list. It's exactly the same as the friends list or contacts list, whatever we called it, right? And then we'll make the like default constructor public array stack, where we just call this with the default capacity. Questions about the constructors? All right. Remember that this one is just constructor chaining. It immediately calls the other constructor with the argument, like this parameter being set to whatever the class's default capacity is, which is defined up here as some static constant. And remember, it's static, so it's not a field of an instance of this class. It's just a value that's tacked onto this class, that exists within this class. Usually there's questions at this point, and the fact that I'm seeing none, again, I don't know, is it because you're all geniuses, or you're all so confused? I think the safe bet is you're all geniuses, right? Yeah, okay, cool. There we go, constructor chaining. Here's a link for you. You go here, and it'll explain why you can't create arrays of type T. There you go. I even include, it's just for you. Oops. All right. When doing this, Java will now warn that it's an unchecked type conversion. Java can't guarantee that the cast will work. This can be ignored. This warning may be suppressed with like what I just said. So now, if I create an instance of this class, that would look something like this by calling this code right here. This is what I would get. Some things to note. Notice the type of the reference variable is the type of the interface. But the type of the thing we're actually creating, the thing on the right-hand side there, is the specific concrete class that we're actually going to create. So the reference variable, all it cares about is as long as it has a reference to something that is a stack. And we're guaranteeing that the array stack is a stack by implementing the stack interface. So the reference variable says it's looking at the interface and being like, okay, this is what I am, and this is what I can do. The actual implementation is over here. By implementing the stack, it's saying, I am this. So anything that wants a stack is going to be happy with an array stack, because an array stack is a stack, right? But not all stacks will be array stacks. We're going to make an entirely different stack. We're going to implement an entirely different stack called a linked stack later. They'll both be stacks, but they'll be implemented entirely different. Notice the type, it's generic. We're specifying this is going to be a stack with integers on it. Mind the fact that it's not int. It's capital I-N-T-E-G-E-R. That's because even though I want ints, you can't put primitive types with generics. You can't do it. So the easy solution is just make a class version of all the primitive types. The class version, the object version of int is integer. Following the pattern, all classes start with an uppercase, right? S is just the reference variable name equals new array stack. So the thing on the right-hand side is the actual concrete class's name. And it's going to have a starting size of 5, because no real reason other than it just is. Yes?
So when you're declaring the variable, stack is class?
Which stack?
The stack integer.
This.
Yes.
That is the type of the reference variable. And the reference variable just cares that it's referencing something that is a stack. An array stack is a stack. I could have written array stack integer s equals new array stack. That would be fine. But it's less general. We're going to come back to this in about a week, I think. And you'll see, you'll really be able to see why it matters. I can motivate it as much as I want right now. But let me put it this way. Imagine I have that line of code there at the top of my program. And I've got like millions of lines of code using this stack for something super important. It's keeping the space shuttle going to space, right? And then someone comes along and they go, hold up, I've got another stack called a super stack. I implemented it, it's way better, right? And then you go, oh shit, okay, so I have to re-implement everything. And then you go, wait, no, I'm a good programmer. All I actually have to do is copy over their code. I have their super stack implementation. That implements a stack. And then my bajillions lines of code keeping the space shuttle in space, I just go to the top and I change half of one line of code. I just change this to super stack. It's still a stack. Every time I used s to push, pop, peek is empty, whatever, because the reference variable doesn't give a shit about the implementation. It only cares about the interface. The actual thing that the reference variable references cares about the implementation because that's going to be how it does what it does. But if the super stack can push and the array stack can push, pop, peek is empty, size, toString equals, then it's fine. So it's like, it's not even changing one line, it's changing half of one line of code and then everything else just kind of like switches out. It's so modular, so it's beautiful, really. It's that type of like well design that makes the hair on the back of your neck stand up, I think. It's magical. Does that answer? Yeah, kind of.
So do you want to keep things generic like that?
Yes, usually we want to deal with the interfaces as much as possible because that's where the what is defined really nicely. And we always want to interface with the what. We never want to think about the how. We try to separate those things as much as possible. Because as soon as you don't, things become inextricably linked and hard to pull apart. And then your code becomes very dependent on itself. Right? You've got all these cross dependencies, and if you want to change out one part, suddenly you need to start to untie and untease all these connections. Where if everything's done in this nice, safe way, it should be easy to just kind of pop out a new piece in there nicely. Okay, so push. Well, I'm just going to go copy this over to array stack here. Let's close this. Close, stack, array stack. So I'm going to update push with an actual working push. Push. If the size is equal to the length of the underlying array, the stack array, its capacity. If I'm full, I gotta expand capacity of that array. Again, expand capacity is a bit of a misnomer. The array doesn't actually get bigger. This just returns a new bigger array. And then regardless, you just add it to index top, increment top, return true. This looks the same as it did before. With contact list, country catalog, course list. Yeah. Any questions about the push? This is just always adding to the end. Yeah?
Can you just use array copy?
Really, it's better to arrays.copy?
System.array copy.
Don't use that one.
Okay.
The problem with that one is it causes a side effect, and it modifies, it's got side effects. But there's one called arrays, with an S, because it's full of a bunch of static methods for arrays. Arrays dot like copy or copy array, I don't remember the name of the method. That one returns a new array. Just like here, I'll show you. I think it arrays dot copy of. So we want the original, probably element, no.
The original and the new stack.
And then stack dot length times 2. I would do something like that, right? For those of you going, what? It's basically this, right? And then we've got our expand capacity. This looks like the expand capacity from before with the contact list. The only big change here is, again, we can't make an array of some type T. We got to make an array of type object and then cast it to type T. Other than that, it's the same. Now you'll notice, like before, that this is a private method. Did this method exist in the interface? Does the stack give a shit about expanding capacity? No. That's an implementation issue. I don't care. That has to do with how push works with your implementation. The stack doesn't care. There's not going to be anything private in an interface. The private is just helping the stack do its thing. The array stack do its thing. So yeah, it's not in the interface. Because expand capacity has nothing to do with stacks. It has to do with array stacks, but not a stack. Yeah? Kind of seeing how it goes now? Okay. Pop and peak. Well, these two are going to be very similar. Now, often, let's just override pop. Peak. Often with collections, your add, which in this case for a stack it's push, your adds will like return a Boolean on the success. And your removes will also return a Boolean on its success or not, in general. But with the stack it's a little bit different. Because when we pop, we don't want it to return a Boolean, we want it to return the thing actually on top of the stack. That's just what a stack is. So this is a specialized data structure where the thing that's removed actually gets returned. But then we're faced with a problem. What happens if what if we have an empty stack and we try to pop from it? Before, with the other remove, we would just return like false if it was unsuccessful, right? But this method, like if you look at the interface, or what we see here, its return type is T. We can't return like a status flag. You could return null, that would be like a sentinel value, but that's, in general, returning null, that's a recipe for disaster. So what we do in this situation is raise an exception. If you try to pop from an empty stack, we really don't have another reasonable choice here other than, well, we're going to throw an exception. The type of exception, no such element exception, with the message empty stack. Don't need the message, but adding the message helps, because if I just see no such element exception, I'm going to go, why? Empty stack. Oh, that's why. Otherwise, if this is, it's just mad because it's not imported. Now it's imported. You don't get it by default. You have to import this. Oops. Otherwise, if it's not empty, get the element at top -1, because remember, top is the next empty spot. So the actual top is at top -1. decrease top, and then return that element. Oh, actually, and I also set it to null because, again, not really strictly necessary, but if the data is not supposed to be there, get rid of it. Who remembers why it's not actually necessary to set this to null? Because top is updated, and top really is what keeps track of what is and is not there. So even though it would still exist, top would reference where it is, and it would immediately get overwritten if anything else was added. But again, if it's not supposed to be there, get rid of it. It's cleaner code. So get the element we want to return, set that spot in the array to null, decrease top, return the element we wanted to return. Yeah?
Instead of keeping track of top, could you just rotate equal to size minus 1?
You could change your fields out such that you do it that way. It's entirely, there's a couple of options you have on how to make it work. This is what I did. Arguably, this is a bad name, because top really isn't top. Maybe it should have been called size. Size is a more appropriate name here. Because top and size are actually not equal. The top is size minus 1. So arguably top, I think, is a bad variable name. So if you think like, well, maybe I should do it entirely reasonable. I'll leave it this way because, but it is a good observation. And if someone, like if I submitted this code and someone did like a code review, so usually when you go to industry, you write some code and then before it gets added to the project, it needs to go through like a review process. If I submitted this, chances are someone may have been like, is top really the best name for this variable, for that field? Because really, it's not top. It's actually like size, which is, from size you can get to top, but that's really not top. And I'd be like, yeah, you're absolutely right. That is a better name. You could say, it doesn't really matter. But having good variable names, I say, really, 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 really matters. And it's not easy to always come up with a good variable name. Peak, it's even simpler than pop because, well, if it's empty, we throw that exception. Otherwise, just return that element. But we're not actually removing it. It stays there. So just return a reference to the thing on the top of the stack, but don't actually eliminate it. Don't update top, don't set anything to null, just leave it there, just return that reference to that thing. Size, well that's easy, that's just return top. And then is empty is like, okay, if size is 0, return true. If this expression ever evaluates to if size returns anything that's not 0, this evaluates to false. Yeah, good. Yeah, this is just talking. Okay, size is empty. Now, toString. How do we actually want? Now, you'll notice toString is not actually in this interface. Right? But everything has a toString because everything is an object at the end of the day. So even though there's no toString there, we could have it here and it would still be reasonable. Our classes can have more public methods than the interface. The requirement is that you at least have these. But everything has a toString because everything has to be an object. The only time I would add an equals, it might be reasonable to add an equals to the interface and then you implement the equals that's in the interface in the thing. If you wanted to add Java docs to the equals in your interface that describes how it should be. What does it mean for two sets to be equal, for example? If I had a set interface. What does it mean to be equal? Maybe I want to be very specific about what a sets equals is. That's when I would put it in there. Otherwise, it's functionally not necessary. So let's look at this toString. And the way I'm doing it here is by no means the correct way. Really, this is a design decision for us to make. How do I want to represent my stack as a string? And the way I wanted to do it is I wanted the thing at the top of the stack, I wanted it to be like as far left as possible. I wanted it to be like the first thing you see in the string. If you think to yourself, that's dumb, it should be the other end. I'm not going to argue with you, that's entirely reasonable. But I wanted it such that the bottom of the stack was over here and the top of the stack was over here. Okay? And so, that's how I wrote my toString. I'm using that string builder thing. And remember, string builder is just a class we use to create a string. It's a little bit more efficient and nice on Java. Otherwise, every time we make a string, we need to make a new string whenever we're appending to it. It's a nightmare. This just basically keeps track of like a list of strings, and then when you're done, it creates one string. But how am I doing this? Well, I'm looping over this, like everything in this, in the actual stack. Remember, we're not going to the array's length, we're going to the size, because the array might have a capacity of 1,000,000, but there's only like 5 things in there. So we only need to loop to size. But what's interesting is I'm always actually inserting at the beginning. So I start at index 0 and put it in a string, and then I go to index 1 of the array, and then I prepend the string with that. So I'm not like appending to a string. I'm not adding on this end. I'm actually like prepending. So right? So that was my lazy way of just getting the top at the front. Because remember, index 0 is always the bottom of the stack. Any questions about this toString? Was that a question?
No, but like I guess you could just start at the top and then just go down to the bottom.
Yeah, I could have. Yeah, I could have gone backwards. Whatever. I just wanted to do it this way. If you're like, yeah, but you could have implemented it this way or that way or this way. Yes, literally an infinite number of ways.
Would that have the comma at the end without anything else?
It would. There would be one trailing comma, but I don't care. The added logic to be like, well, if it's the first time, don't actually add a comma. Forget it. I'm not going to add that logic in there. There's this design philosophy, by the way. And this is an important design philosophy for young people to understand. It's a design philosophy called worse is better. If I have, it is so much better to have a simple solution, a beautiful, simple solution that is like good enough, than it is to have an insanely complex solution that is always like immaculately perfect. Correctness is correctness. But you ever hear like that Pareto thing, that 80-20 rule? You ever hear that? Where like it requires 20% of the work to catch like 80% of the cases. It's like the last mile problem, right? It's easy to solve a problem this much, but if you want to catch all those like edge cases and nuance, it requires a lot more work. It kind of follows that idea. This would be an example of worse is better. It's simple and it's fine. But if someone came to me and be like, get rid of that extra comma, like I could do that, but it adds complexity. Not a lot, but it does add complexity. So I don't want to do it. And if they call me lazy, I go like, the reason this is better is this is more generally applicable, which is a good thing. And it allows me to be lazy. So it's good for two reasons, right? People always get suspicious when, never mind. Anyways, worse is better. But correctness is still correctness, right? That comma wouldn't make it incorrect, right? So it still needs to be correct. Other questions about this toString though? Anything? All right. And then equals and hash code. Well, this is going to look a hell of a lot like all the other ones we've seen so far. Got to import the arrays class and then the objects class as well. If they're literally the same thing, it's true. If O is null or their classes don't match, it's false. Otherwise, cast it as an array stack and just check if the arrays are actually equal. Right? Yeah. You might say, why don't you also check if the sizes are equal? You only check the arrays field. And you're not wrong, but this would catch that fact, right? And then hash code, just hash each individual thing in that array. With that whole weird thing where we multiply it by that prime 97 because it's magic. I looked it up once, and one of the best explanations, like I was like, why 97? Everyone knows it's important to be like a prime. It really doesn't matter. But 97 is like the recommended one. And I looked it up once, and the best answer I got out of my understanding of it was, it's just magic. So I was like, all right, good enough. I trust you. People who know way more than me have assured me that it's better this way, so that's all I can tell you. Why not 31? I don't know. 31's prime, right? Yeah. Let's assume it is. All right, cool. So there we go. These look basically the same as the other hash codes we've done so far. Now, I will warn you, there is a bit of a deficiency with this equals. And we will revisit this like 3/4 of the way through the course. But I will give you a bit of a hint right now. This equals would only ever allow me to compare array stacks. But what if I wanted to check if an array stack and a superstack, remember that silly superstack example, are equal? This equals wouldn't work like that. Now the reason I couldn't make it work is there's a couple of things we don't know yet, so we're not going to touch that right now. But there is a bit of a deficiency with this equals as it is. Any questions or anything? Yes?
So, the array stack is a stack because it has all the methods from the stack interface.
Because, one, it has all the methods. They're implemented correctly, though that's not a requirement to be considered a stack. And we put that keyword in there that then, if I implemented all the methods, but I didn't say implements, Java's going to be like, I don't trust you. When you say implements, and then it does the check that, yes, you did in fact actually implement everything, then it is officially actually a stack.
But we can add in other methods.
Yep, we could.
So, if, like, I know you said don't add other methods that make it not a stack. But is there anything that checks for that? Like, if we made a method that did something.
If I added a method called count to 10, right, to this stack, all array stacks could count to 10. But not all stacks could. All array stacks can. All array stacks are stacks, but not all stacks are array stacks. And there's no guarantee that a stack has a count to 10 method. The equals hash code and to string are guaranteed to exist because everything is an object and it inherits from it, and you get those for free anyways. Yeah. Hold on to that question though, because it'll probably make more sense the more we learn along the way. All right, see y'all later.